Hello everyone, I'm Hina Chandak, one of the TAs for the Introduction to Deep Learning course. So in our previous recitation, we dwelled into the workings of PyTorch datasets. In this recitation, we will be mostly discussing the homework-related bits that are specific to audio datasets. So let's get started. So in Homework 1 Part 2, we will be dealing with MFCC speech data. It's a format derived from raw waveform data. The process of calculating it is not required in this course, but we will be covering that in Recitation 1. However, for now, we'll provide you with a glimpse of the dataset structure and also guide you through loading a single training sample. So as you can see, after you download the dataset, you'll encounter a folder structure with the folders as train clean 100, dev clean, and test clean. We use the train clean 100 folder for training our model, the dev clean for evaluating our model, and the test clean for prediction and Kaggle submission. Now, let us take a look at a single training sample. So here, we load a speech sample from the train clean folder along with its transcript. Each speech data is organized as an array with shape t times 27. So here t is basically the total time steps for that sample, and 27 is the number of features for the MFCC file format. As you can see, for this particular training sample, we have 1404 time steps and 27 features for each time step. As for the transcript, it is organized as a 1D array with t plus 2. Here, the two extra time steps are SOS and EOS tokens, which stand for start of sequence and end of sequence, that are located in the beginning and the end, respectively. Note, for homework 1, these two tokens are not needed. So you might have to think how to remove them in your homework 1 part 2 for your pre-processing pipeline. Another important technique that we're going to use for homework 1 part 2 is the context information. Proper management of local context is essential to homework 1, in which we are going to predict the phoneme for each of the time steps. The dominant solutions in the past were set in a handcrafted context with the following approaches. That is either derivatives or context windows. In this homework, we're going to apply context windows. So what these context windows essentially do is that they add a local context by simply concatenating multiple consecutive time steps. The result now is a bigger feature vector that is better aware of the local information. For example, originally the input of the network and the expected output of the network for time step 64 would look like this. Now, if we apply a context of 10 to the 64th time step, how we can do this is that we can concatenate features from 10 past and 10 future frames. So we create a new variable, x with context. After concatenating the context, the shape of x is now 21 times 27. Also, since we are designing an MLP network, we might want to flatten an x to a 1D array as it is a single training sample. So all in all, in this video, we have covered the dataset structure, how to load training samples, and the importance of context windows for homework 1 part 2. Thank you so much.